Hi friends, welcome back to the Rank Master series and I am Mahendra. Today we are diving deep into one of the most critical but overlooked aspects of that, that is document checking strategies. And I will also explaining how to handle different document types. By the end of this video, you will understand why checking matters most and how to implement different checking techniques, and you will know which checking strategy will work better for your use case. And you will also understand how to handle different document types like HTML, PDF, JSON, and any other else with coding implementation. To make the video shorter, I have already written the code for this and I will be explaining the code directly. So without wasting the time, let's get started. Picture this, you have built your RAG system and loaded your company's employee handbook and it seems to be working perfect. Let's say your manager asks you, what's our policy on vacation at 12 for part-time employees? Your RAG system confidently says vacation policies were present in the section 4.2 and part-time employees are eligible for certain benefits. But it completely misses the equivalent rates that were present 3 sentences later in the same policy section. So basically, it's the main thinking problem in action. Your document is split in the middle of important information and your RAG system cannot connect these dots. So in this video, we will be solving this problem of chunking by using different chunking strategies. Okay, let us understand what is document chunking with a simple example. Simply, document chunking is breaking down large documents into simpler, manageable, and smaller pieces that can be processed by our RAG system. Let us understand it with a small example. It is like cutting a pizza. We need each slice to be of equal size and each slice should contain flowers that belong together. But why we need chunking? There are mainly 3 reasons for that. The first one was vector database limitation. Most embedding models work best with the text segments of 200 to 500 tokens. If you fed with 50 pages document, the most important information may get lost in the noise. The second was retrieval precision. Smaller chunks meaning more precise retrieval. Instead of retrieving a chapter when you need one specific fact, it will give you what you are looking for. The third one was cost efficiency. Processing smaller chunks is faster and cheaper when compared to dealing with massive text blocks every time. The key insight was good chunking preserves the meaning and optimizing for retrieval. Let us start with a simple chunking strategy, that is fixed size chunking. This is like cutting a document into equal parts irrespective of content present in the document. Let's say this is a document and in fixed size chunking, you will cut the document into equal size. Let's say it is X, it is size Y, Z, W. Here, all these variables have the equal size N. This is called fixed size chunking. It does not consider the content that present in the document. Okay, let's discuss about when fixed size chunking works well and when it will struggle you. Coming to when it works better with consistent document structure while using technical manuals when your processing speed is critical rather than accuracy. And when your use case is a simple Q&A scenario, you can use fixed size chunking. And if you are a beginner and you are getting started with the chunking, you can start from understanding fixed size chunking. And coming to the struggles related to fixed size chunking, when a document with varied content density, fixed size chunking is not applicable because fixed size chunking do not consider the content present in the document. So it will cut in the middle of some important information. And the second was when your document or data is document tables or lists is not applicable because fixed size chunking will cut in between the table columns or rows. And the third limitation is when you are dealing with legal documents where your context is everything and important, you should not use fixed size chunking. Let's take example. Was fixed size chunking split clause 5.2 continues from 5.1 and defines key terms. Dot dot dot. Across chunks breaks the logic chain. And the fourth one was creative content like stories and articles. If you use fixed size chunking in this scenario, a chunk might end with dialogue or mixing, which is not understandable for the user. So these are the four scenarios where you should not use fixed size chunking. And these were the four where you can use fixed size chunking, but you should spare accuracy in this case. Now let's level up to semantic chunking. This is where we respect natural boundaries of the content. Instead of arbitrary cuts, we preserve the meaning and context present in the document. So semantic chunking is basically breaking the document at full stops or apostrophes, which will preserve the meaning, right? Don't worry, I will be explaining the code for these chunking strategies. Once I explain different types of chunking and what is the meaning and some examples. Coming to the advantages of semantic chunking, the first one was it preserves complete thoughts and concepts. Semantic chunking respects natural document structure. So it is better context preservation. So retrieval results will be more meaningful. So let us understand semantic chunking with an example. Instead of cutting the sentence in the middle, like the company vacation policy states that full-time employees accrue 50 days annually, while part-time employees working more than 20 hours per week accrue 10 days annually. The semantic chunking will keep this whole sentence together. But if we use fixed size chunking, it may cut this sentence maybe here or here. See, there is some lost in the important information which we require. So this is the advantage of semantic chunking. Let's talk about one of the most important concepts in chunking, that is overlapping windows. This technique ensures that important information spanning chunk boundaries doesn't get lost. Let us understand with a simple example. Let's say this is a document. The first chunk break this document, suppose at a length 2. The next chunk will continue from somewhat before the boundary of the previous chunk. Means, let's say from here to here. The next third chunk will start from here to here. So, by using overlapping window, we will maintain that context that was present at the boundaries. So, we will not lost the information that was present at the boundaries using overlapping windows. So, coming to why overlapping matters, as we discussed it, the main was context continuity. Let's say if a question answers spans two chunks. Overlapping ensures both chunks contain enough context to be relevant. The second was relationship preservation. Con- Concepts that reference each other across boundaries stay connected. The third was better retrieval results. Multiple chunks with overlapping context provide richer and more complete answers. Coming to the optimal overlap sizes, 10 to 20% overlap size for general content, 25 to 30% for technical documents, and up to 50% for legal and medical content documents. Yes. First, we will be importing all the required libraries. And I will be first importing NLTK. Next, sentence underscore tokenize from NLTK. I will be using it for splitting the text into sentences. Next, I will be importing RE. It is used for cleaning and splitting of text. Next, I have defined a function for cleaning and organizing the text. This function removes all the white space characters like tab and namespaces that present in between the text, and also it will return the text, removing all the leading and trailing white spaces. So I have defined a function for fixed size chunking with arguments. This was the input text we will be giving, and I defined a chunk size of 500 with a overlap of 50. Here I have mentioned minimum length is equal to 100. This means the chunk size should be always greater than this minimum length. Okay. So coming to the function, first the input text is cleaned and organized by this function. Next I have initiated a empty list called chunks and a variable start equal to 0. And I will be running the while loop until it reaches the end of the text. So first I will be initiating the start and end points for the text, and is equal to start plus chunk size. Next, if the chunk is not empty and the length of the chunk is greater than or equal to minimum length, it will be appended to the unfinished that we have defined as chunk. After, we will be redefining the start and end points. If it reaches the end of the sentence, it will break the while loop. So this is the function for the fixed size checking. And coming to the sentence based checking function, here also the same. The arguments will input text and next it will be maximum sentences. As we discussed, sentence based chunking means uh, not a arbitrary cut. The whole sentences we will be considering. Like I have discussed before, semantic chunking means it will divide the text and full stop or the marks to be meaningful. And I have given a overlapping sentence equal to 1 and as before, the minimum length equal to 100. So first I will text is clean and normalize it. And we use a sentence underscore tokenize function to split the text into sentences. Initiate a unfinished, for instance, and a variable I equal to 0. We will be running this loop until I will be less than length of sentences. This force effect will remove all the maximum sentences into one chunk. And if the chunk text is not empty and the length is greater than or equal to minimum length, they will be appended into the chunk list. And here we will be reinstating the I variable based on the maximum sentences and the overlap sentences. The next, coming to the paragraph based chunking, the arguments will be input text. And if you need overlap paragraphs, you can change it to one or two based on your use case and interest. As before, the minimum length is specified as 100. First step will be clean and normalize the text. This function is used to split the text into paragraphs. We will be assuming paragraphs are separated by double line breaks. So we will be using slash and as delimiter to split the text into paragraphs. And next, initiate the empty list functions. Here, I is the current index of the paragraph, and paragraph is the actual content. This function is used for overlapping paragraphs. If overlap is unknown, this function concatenate the current paragraph with the previous paragraph and add it to the chunk text. If the chunk text is not empty and the length is greater than minimum length, it will be appended to the chunks. Next, coming to the overlapping chunking function. Here the arguments were input text, chunk size, and overlap size. Okay, I have defined it as before chunk size is 500 and overlap size is 100. First, we will be splitting the text into sentences. The first we will be splitting like full stop, question mark, or exclamatory mark. Then we will be removing all the leading and trailing white spaces from the sentences. Next, initiate the empty list and variable I is equal to 0. We will be running the while loop until I less than length of sentence is satisfied. Next, we will be initiating another empty list. Force effect will collect sentences until the chunk size is reached and it will add it to the second empty list we have initialized. And this is the force effect for maintaining overlap between the current sentence and the previous sentence. And then after overlapping, it will be added to the original chunks and it will return the chunks. And next, coming to the document processor, I have defined it like this. In this .py file, I will be discussing how to extract text from different formats. First, we will be extracting text from PDF. I have defined this function, and I will be using IPDF2 library from Python. Uh, Using .pdf reader, I will be reading the input file and extracting the text from each page. Think of each page as text to a empty string. And next, we will be defining the function for extracting text from CSV. First, we will be using pd.read CSV to read that CSV file, and we'll be using string IO function for converting the string into an object. Next, if we want to include headers, then this code snippet will add the headers separated by comma in the first line. Next, the content of the CSV file. That is first, it will ensure each content is in the form of string, and then we will apply a lambda function, which will join all the rows separated by comma and add it to the rows list. And this is the function for extracting the text from JSON. Next, for extracting text from text, we will be writing this code snippet, open file path in read format and f.read. So these are some functions for cleaning the text, removing white spaces, filing and leaving white spaces. Right. So don't worry, I will be providing all the code in the GitHub with proper documentation so that you can understand it very well, line by line. If you have any doubts, you can comment me or you can contact me through my email and even in GitHub itself. Actually, in our previous videos, I have taught you how to build our own chatbot. So in that, I have discussed only one chunking strategy and processing of only PDF. So using these chunking strategies and document processor.py file, I have remodified the chatbot so that it can take multiple input document types. And so I will be providing the link for the GitHub in the description. So please feel free to go to my GitHub and access the code and experiment with it. And there will be a replay file for this folder. It will guide you in how to implement things and how to run the app. I will be using Streamlit interface for designing this RAG chatbot because using Streamlit is easy to make web applications in Python. Let us talk about best practices and common pitfalls that separate amateur chunking from professional build implementations. Coming to the best practices, the first one was know your content before choosing a chunking strategy. Understand your document types. Generally, technical manuals need different treatment than a creative writing. Next, test with real queries. Don't just chunk and hope. Test with actual questions your users will ask. So you will understand which chunking strategy you should use and what should be its parameters or arguments. Maintain metadata. Always keep track of where the chunk came from. These three are the best practices to be followed while considering chunking strategies and their arguments. Next, coming to the common pitfalls to be avoided. The first one was one size fits all. Don't use the same chunking strategy for all documents. A legal contract needs different treatment than a product manual. Ignoring document structures. Headers, bullet points, and sections breaks exist for a reason. You should respect them and you should consider them. Chunks too large or too small. Generally, too small chunks lack context and noise retrieval, and too large have diluted relevance and expensive processing. So, as I said before, you should test your questions and based on that, you should keep the chunk size to be optimum. Next, forgetting about special content. Generally, some content will have code blocks, formulas, tables. These need some special handling or they become meaningless fragments and not testing the edge cases. What happens with very short documents, empty sections, documents with only tables? You should consider all these edge cases before fixing a chunking strategy. Basically, they have some different approach for chunking to get valuable data to be extracted from them. Next, choosing the right strategy. Step one, analyze your content first. If your content has consistent structure, consider fixed size with smart overlap as I discussed in the code. If your content has varied types, go with semantic. If your content has lots of tables or lists, consider custom structure reserving approach. Step two, consider your use case. If your use case was a simple question and answer, paragraph-based chunking works well. If your use case is a complex reasoning, larger chunks with more context should be considered. If you want fast retrieval, smaller but more focused chunks. The step three is focus factor in your resources. If you have limited processing power, go with simple fixed size. And if you need maximum accuracy, invest in semantic chunking. Handling multiple languages, sentence-based is safer when compared to other strategies. If this video helped you understand chunking strategies and how to handle different document types, feedback like button, subscribe for the complete Track Master series. If you have any questions, feel free to comment and you can mail me about the doubts you have with the code or any implementation. Thanks for watching and I will see you in the next video where we dive into the next parts of our Brand Master series.